We're going to use a positive u, but only one of them. But now we're using a negative v, so instead of going 2 to the left and 4 down, we're going to go 2 to the right and 4 up. So there's negative v, which means that my red vector here is u minus v. And those are your graphical representations. Now for part B, I want you to determine the component forms of those vectors that we found. So determine the components of negative 2u, 3u plus v, and u minus v. Then find the magnitudes of u and v. Again, if you want to, you can try this on your own first and then resume the video when you're ready to check your solutions. Alright, first things first, I know that u's component form is 2, 0, because we're going 2 to the right and we're not going up or down. V's component form is negative 2, negative 4, because we're going 2 to the left and then 4 down. This will help me for these questions. Alright, for negative 2u, that's going to be negative 2 times the vector 2, 0, which is going to be negative 4, 0. And indeed, that's what I found when I sketched out negative 2u. Okay, let's look at 3u plus v. This is going to be multiplying u by a scalar of 3 and then adding vector v, which is going to equal 6, 0 plus negative 2, negative 4, which is going to be 6 minus 2, that's 4, and then 0 minus 4 is negative 4. That is 3u plus v. Alright, lastly, let's look at u minus v. I'm going to take the vector u, 2, 0, minus the vector v of negative 2, negative 4. This is the same as 2, 0 plus 2, 4. We change the signs. 2 plus 2 is 4. 0 plus 4 is 4. So we get the vector 4, 4. And in fact, when I sketched out u minus v, I see it's 4 and then 4. So u minus v is indeed a vector that has the component 4, 4. And those are your 3 answers. Alright, this brings us to the topic of a unit vector. A unit vector is a vector with a magnitude of 1. We do have 2 very special unit vectors. I is a unit vector that is 1, 0. So it's a unit vector that is completely in the direction of a horizontal distance. J is a unit vector in vertical distance, so it's a vector that's 0, 1. What this means is we can use these unit vectors to break the vectors that we've been looking at into a linear combination. Linear combination of u will look like, well, what linear combination is writing a vector in terms of a combination of vectors I and j. So you really do need to have I and j well defined and know what those are. In particular, the way we do this is we break u in its component form of u1, u2 to u1 times I plus u2 times j, where u1 and u2 now become scalars. And let's look at this with example 3. You're given vector u, which is negative 5, 3. We're going to find the unit vector that points in the same direction as u, and then we're going to find the linear combination of I and j that is equivalent to u.